AMC 10A 2019 Problem 15. We're given this recursive series, given the first two terms, and we're trying to find P plus Q, where it is written in the form of P over Q and they're relatively prime to each other. So what does it mean to be relatively prime? Because we need to understand that to understand how to solve the question. So relatively prime just means that two numbers such as n and m share only a common factor of 1. It means that the only greatest common divisor or greatest common factor is just 1. That's what it means to be relatively prime to each other. But that's not really important. Well, it is important, but it's not the main focus of this question. The main focus is how to find P and Q. And to find P and Q, we just have to continuously apply to the recursive series. And recursive series are special because the series, you can find later terms given the criteria and a general formula with the first two terms. And that is exactly what we're given with. So let's just follow it through. A's of 1 is 1, A's of 2 is 3 over 7. And now we're trying to find A's of 3. So A's of 3 will be the same thing as A's of 1 times A's of 2 over 2 times A's of 1 minus A's of 2. Now A's of 1 is 1 times A's of 2 is 3 over 7 over 2 times 1, which is 2, minus A's of 2, which is 3 over 7. This is the same thing as 3 over 7 times 7 over 11, which is 3 over 11. So A's of 3 is 3 over 11. Now, is there something special about this that we can already deduce from? Well, we can. What can we rewrite 3 as? Or A's of 1 as? We can rewrite A's of 1, which is 1, as 3 over 3. And why do you think that I had the idea to write it as such? Because I see here that the numerator is always 3. It's static. And I can change A's of 1 so that it can match this very pattern. And when I change it, this numerator is static. But look at what the denominator is doing. 3 jumps to 7, which jumps to 11. They all have a common difference of 4. But let's see if this actually holds out by testing for A's of 4. So A's of 4 will be the same thing as A's of 2 times A's of 3 over 2 times A's of 2 minus A's of 3. So this is the same thing as 3 over 7 times A's of 3, 3 over 11, 2 times 3 over 7 minus 3 over 11. This is the same thing as 9 over 77 times 6 over 7 minus 3 over 11, which is the same thing as 9 over 77 times 77 over 66 minus 21, which is 45, which is the same thing as 9 over 45, which we can simplify to 1 over 5. So A's of 4 is nothing more but 1 over 5. But how can we rewrite this to be the same as a static numerator of 3? Just multiply 3 over 3 on both sides, we get 3 over 15. And now we see here that 11 jumps to 15, and this common difference of 4 is also maintained. So we can be sure that this sequence will follow throughout. But how can we write a general formula in relation to n and the denominator? And why do I want to relate n with the denominator? It is because we're trying to find A's of 2019. We know this recursive series, but we do not know a general formula that can help us find the value no matter the nth term. And this is not a general formula. This is just a sequence in a pattern. So you must find it. And it's actually very simple because I see here that this series all have a common difference of 4. So this is actually called a Newton series. In a Newton series, we depend on the degree power. And by the degree power, I mean how many terms must it go through until it has a static difference, like 4. Well, this is only one layer, so this is a first degree Newton series. And to understand and to find the general formula for a Newton series, it's very simple. Since this is a first degree series, Newton series, then it must mean that it must be a linear form, an plus b, where a and b are variables that we need to solve for. And this will be equal to some y, depending on the n. So when n is equal to 1, n is the place value for each of these terms. So when n is equal to 1, our constant is 3. So y is of 1, which is the same thing as 3, is a times n, which is 1, plus b. And y is of 2, likewise, will be 2a plus b. But what is y is of 2? Y is of 2 is 7. So we have two variables and we have two equations. We can solve the variables. So 2a plus b is equal to 7 and a plus b is equal to 3. We can subtract the second term from the first term to get a is equal to 4. Hence, a is equal to 4, we plug it into equation 2, we get b is equal to negative 1. So the general formula for this recursive series will be 4n minus 1. And this will be the general formula that can help us solve the term number given the nth term. So we're trying to find the 2019 term, so 4 times 2019 minus 1 will give us the answer. This is the same thing as 8076 minus 1, which is 8075. So the fraction at A of 2019 will be the same thing as 3 over 8075. That is the fraction at the nth 2019 term. And since these are relatively prime to each other, because 8075 cannot be summed to a number that is divisible by 3, we are done. So we have to find P plus Q, so this becomes 8078. And when I look up and I see here that answer choice E is our answer.